This is a worked problem video on cylindrical shells. Here's the statement of the problem. We want to find a region bounded by these three curves and the x-axis, and then that region will be rotated about the y-axis. This is the defined region. That region is bounded by the curve y equals 1 minus x squared. X squared tells us that we're going to graph a parabola. Negative x squared tells us it will open downwards. 1 minus x squared means that we can only get as large as 1. The other two equations, x equals 0 and x equals 1, are vertical lines. And then they are providing bounds of integration, as we will end up integrating with respect to x, since we want to rotate about the y-axis. Picking an x between our bounds of integration, 0 and 1, and looking at a line segment contained in our region, we see that the line segment will have a height of f of x. That line segment we rotate about the y-axis to produce a cylinder. This cylinder has a radius of x and a height of f of x. And recall that f of x for us is 1 minus x squared, the parabola. We want to use the radius and the height to find the area of the cylinder. A of x denotes the area of this cylinder. We take the circumference of the circle times the height to get the area of the cylinder. 2 pi is 2 pi, the radius is x, and the height is 1 minus x squared. The volume integral is the definite integral with integrand a of x. I've pulled out the constant 2 pi and left the x multiplying 1 minus x squared as the integrand. This is an elementary integral. X will integrate up to x squared over 2. X to the third evaluates to x to the fourth over 4. Our bounds are nice and simple. Lower bound 0, upper bound 1. So that when we plug in, we only have to evaluate at 1, which becomes 1/2 minus a fourth. And then we use that 2 over 4 is equal to 1/2, which is our answer. And that is a worked problem on cylindrical shells. Excellent.